All right, welcome back to the deep dive. Ready to dive into something kind of cool today?
Always. What are we looking at today?
Well, today we're talking about something you do every day, without even thinking about it. How your brain groups things together, visually.
Oh, very interesting.
Yeah. We see like a jumble of objects and our brains just go boom, sorted.
Yeah, that's right.
But the real cool stuff is like what's happening behind the scenes to make that, happen.
The behind the scenes is always the most fascinating part.
Right. Like it just feels so effortless. But
it does.
To break it down, we're looking at this research from Georgia Tech.
Okay.
Specifically, Vijay Marupudi and Sashank Varma, they're over in the schools of psychology and interactive computing.
Okay.
And they wanted to understand this visual clustering in a really precise way.
Right.
So they designed this experiment where people basically, they looked at dots on the screen and had to circle the groups they saw.
Okay.
And then the researchers dug into those groupings, looking for patterns.
Yeah.
I see. Trying to figure out what rules our brains might be following. So
That's cool.
It's really fascinating stuff. So
yeah.
First things first, did they find out if we're all seeing the same groups? Or is it just kind of random? What do you think?
Well, that was a big question. And I think the results were really interesting.
Okay.
First, they found that each person is really consistent.
Okay.
So if you clustered the same dots twice, your groupings would be remarkably similar.
So it's not just me randomly circling things. My brain actually has a method to the madness.
Exactly. Yeah, it's like you have your signature clustering style.
Okay, I like that.
To measure this, they use something called the Falks-Mallows index.
Oh, that sounds complicated.
It is, but you can think of it like, a percentage match.
Okay.
So how similar are your two sets of clusters?
Got it.
And they found that the average match was over 75%.
All right.
Which is, that's pretty amazing.
Wow. That's way more consistent than I would have guessed. But what about between different people? Are we all on the same wavelength?
So there was a good amount of agreement between people, too.
Really?
Yeah, not as high as within individuals, but still.
Okay.
The average match was still over 60%.
Wow. So we're more similar than I thought.
Yeah. So even though it feels so effortless, it seems like there are some underlying principles guiding how humans, cluster visual information.
Okay, so we have a knack for this, and there's some consistency to it.
Yes.
But did they find out anything about the shapes of the clusters themselves? Are they all blobs or lines, or what did they find?
Well, this might surprise you. They found that a lot of the larger clusters actually tended to resemble, that classic bell curve shape, high in the middle and sloping down on the sides.
Yeah.
Formerly called a Gaussian or normal distribution.
Right, yeah.
But the bell curve image is really what we're thinking about here.
Oh, yeah. Interesting. So even when the dots are, randomly placed, our brains seem to prefer grouping them in, kind of a balanced, ordered way.
That's the idea. It's
Wow.
like there's this underlying preference for a certain visual harmony.
Okay.
And what's really neat is that this finding actually lines up with research in other areas of perception,
What else?
how we see colors and angles.
Oh, interesting.
And it seems like our brains are just drawn to these types of distributions.
That's wild. So it's not just randomness. There are deeper patterns at play here.
Definitely.
Speaking of patterns, did the researchers try making the dots more or less obviously grouped to see how that, impacted people's clustering?
They did. They varied something called cluster structure.
Okay.
So some sets of dots were very clearly clumped together,
Okay.
while others were more spread out and ambiguous.
Oh, no.
And they even had a way to measure this objectively using a spatial clustering coefficient, but we don't have to go into all that.
That sounds complicated.
It is, yeah.
But so did that throw people off or make them less consistent?
Actually, the opposite happened. When the dots were more obviously clustered, people were even more consistent, both with themselves and with each other.
Wait, so more structure actually made us better at clustering. That's counterintuitive.
It is. But think about it this way. Imagine you're organizing a drawer full of stuff.
Okay.
The more items you have, the more containers you'd probably use.
Yeah, that's true.
And the more you'd put in each one, right? It's like our brains become more confident and consistent when we have those clear visual cues to work with.
Okay, that makes sense, yeah.
Yeah.
So it's not just about finding any old groups. It's about finding the right number and size of groups based on the information we're seeing.
Exactly.
But how did they know if the clusters people were making were actually good clusters? Is there some kind of a scoring system for that?
That's a great question. There's no single right answer. really, when it comes to clustering.
Right.
But they did use a few different quality metrics, and these are basically like scoring systems to evaluate how, well-defined and internally cohesive the clusters were.
I see. So, it's like judging a baking competition, but for clusters.
That's a great analogy. Exactly.
Okay, I like that.
Yeah.
So how did we do? Were we making, delicious prize-winning clusters?
Overall, people did a really great job, especially with those clearly clustered sets of dots.
Nice.
The clusters tended to score highly on those quality metrics.
Okay.
And it really implies that our brains are pretty darn good at picking out meaningful patterns. Like we're natural-born pattern seekers, really.
That's reassuring.
It is, yeah.
So we've got consistency, we've got bell curves, we've got good quality clusters.
We do.
What else did they find out about, how we build these groups?
Well, they looked at a bunch of different attributes, like how many dots were in each cluster, that's numerosity, how much area they covered, how densely packed they were, and even how much they resembled a straight line, that's linearity.
Okay, got it.
Yeah.
So anything particularly interesting about those attributes? Anything that surprised the researchers?
Actually, yes. They noticed that people didn't try to keep the number of clusters,
Okay.
or the size of each cluster constant as the number of dots increased.
Interesting.
Instead, they adapted their strategies. Both the number and size of the clusters went up.
Huh, okay.
So it's like our brains are constantly adjusting to the amount of information we're taking in.
Fascinating. So it's not just about finding the same number of groups every time, but about finding the right number of groups for the situation.
Exactly.
That's a clever way for our brains to handle complexity.
It is, yeah.
Anything else about the attributes that stood out?
They also looked at something called convex hull percentage.
Okay, that sounds kind of complicated.
It sounds complicated, but just picture tracing the outer edge of a cluster like that's its convex hull. The percentage tells you how much of the cluster is defined by that outer edge. So a high percentage means it's more hollow inside.
Got it. So a really solid cluster would have a low convex hole percentage.
Right.
And a more donut-like cluster would have a high one.
Exactly, yeah.
Did they find any patterns in how people use this hollowness?
Interestingly, they found that people tended to create their first clusters as the largest, densest, and least hollow ones.
Okay.
They saved those singleton dots or smaller, hollower clusters for last.
So it's like they went for the most obvious, well-defined groups first,
Right.
and then tackled the trickier, less certain ones later.
Exactly.
That seems pretty efficient.
It does, and it suggests a strategic element to visual clustering. It's not just random.
Right.
We're prioritizing certain characteristics and using them to make decisions about how to group things.
This is so cool. I never realized how much was going on in my brain when I'm, just looking at a bunch of dots.
It's amazing how much complexity is hidden in such a seemingly simple task.
It really is.
And it gets even more interesting when you start to think about how this visual clustering might connect to other cognitive abilities.
Hold on. You're saying how we cluster dots on a screen could be related to things like problem solving or even math.
That's exactly what I'm getting at. Think about it. Clustering is all about finding patterns and organizing information.
Right.
And those are fundamental skills that we use in so many areas of our lives.
Okay, I'm intrigued.
Yeah.
Tell me more. Okay, I'm starting to see the connection. Give me an example.
Sure.
How does this dot clustering relate to something like problem solving?
So imagine you're trying to plan a big trip.
Right.
It can feel overwhelming at first.
Oh, yeah.
But what do you naturally start doing? You start breaking the problem down.
Right.
Flights, hotels, activities, you create smaller, manageable chunks.
Right, you got to make lists.
Exactly. So it's like you're visually clustering those tasks in your mind.
I'll go cut.
Even though they're not, physical objects.
Yeah, so it's like I'm visually clustering those tasks in my mind, even though they aren't, physical objects.
Exactly. You're grouping related ideas together.
Right.
And it's not just planning. Think about data visualization.
Okay.
When we look at a chart or graph, our brains automatically start grouping similar data points,
Yeah, that's true.
picking out trends and patterns.
So understanding how we visually cluster could actually help us design better charts and graphs,
Absolutely.
making them easier for people to interpret.
Right. Exactly.
That's powerful.
It is. And this visual clustering might also play a role in something called numerosity estimation.
Okay, break that down for me.
So that's the ability to quickly judge how many things are in a group.
Oh, yeah. Okay, some people are amazing at that. They glance at a crowd and know exactly how many people are there.
Right. And researchers are exploring whether our visual clustering ability contributes to that.
Okay.
Think about it. When you see a lot of objects, your brain might first cluster them visually and then use those clusters as like a shortcut
Okay.
to estimate the total number.
Wow. So something as seemingly simple as grouping things together could be like a building block for a more complex skill.
It really could.
Makes you wonder if we could like train people to become better at visual clustering
Oh, interesting.
and then see if that improves their other cognitive abilities.
That's a fascinating question, and it's definitely something researchers are starting to investigate.
Cool.
There's already some evidence suggesting that practicing visual tasks can improve things like attention and working memory,
Right.
both of which are crucial for all sorts of higher level thinking.
This is blowing my mind. We're talking about dots on a screen, but the implications are so much bigger.
They are, aren't they?
It's like we're uncovering these hidden connections in how our brains work.
Exactly. The more we understand about these, basic processes,
Right.
the more we can potentially leverage them to improve learning, design, and maybe even boost our cognitive performance.
Okay, so let's recap what we've learned today. So first, we're surprisingly consistent in how we cluster things visually,
Yes,
both individually and as a species.
that's right.
And those clusters often have that classic bell curve shape,
Yes.
suggesting, an innate preference for balance and order. And plus, we're really good at making, high-quality clusters, even without realizing it.
Exactly, we are.
Which is kind of cool. And we've explored the tantalizing possibility that these clustering skills might be connected to broader cognitive abilities like problem solving,
That's right.
data visualization, even numerosity estimation.
Amazing, isn't it?
It really is amazing. But what does this all mean for our listeners out there in the real world? How can they use this knowledge in their everyday lives?
Well, I think the first step is simply awareness.
Yeah.
So the next time you're faced with, a complex task, a cluttered space,
Right.
or even just a beautiful piece of art, pay attention to how your brain is naturally grouping things.
Oh, that's interesting.
You might gain some insights into your own thought processes.
I love that. Just becoming more mindful of our visual clustering tendencies could be incredibly valuable.
It could, absolutely.
And if you work with data or presentations, think about how you can leverage those bell curves and clustering principles to make your visuals more effective and impactful.
Definitely.
Such a practical tip. But, this research also challenges a long-held assumption about babies and how they perceive the world.
You mean the idea that babies are bombarded with sensory information?
Yeah, experiencing, a blooming, buzzing confusion.
Right, the classic idea.
Exactly. But these findings suggest that even our most fundamental visual processes are incredibly sophisticated,
They are.
capable of finding order and meaning in what seems like, chaos.
Yeah, it turns out we might be wired for pattern recognition from the very beginning.
That's amazing.
Maybe our brains aren't overwhelmed by the world, but excited by the opportunity to make sense of it.
This deep dive has been a real eye-opener for me. I'm already seeing the world differently.
That's great to hear.
Before we wrap up, is there anything else you'd like our listeners to ponder?
Sure.
Any unanswered questions or directions for future research?
Well, one thing that fascinates me is the potential for education.
Oh, interesting.
Could we design better learning materials or user interfaces that take advantage of how our brains naturally cluster information?
That's a great question. Imagine if we could help students become better learners by explicitly training their visual clustering skills.
Exactly. And what about the impact of technology?
Oh, yeah.
How do things like social media and virtual reality influence our visual clustering processes? These are all areas ripe for exploration.
This is just the beginning. A huge thanks to you for, guiding us through this incredible research.
It's been a pleasure.
And to all of you listening, thanks for joining us on this journey into the fascinating world of visual clustering.
It really is a fascinating world.
Remember, the world is full of patterns, just waiting to be discovered. So until next time, keep those eyes peeled and those minds curious.
I love that.
It's amazing to think that something as simple as grouping dots together can unlock so much about how our brains work.
Yeah, it really is.
And this research from Georgia Tech really opens up like a whole new way of thinking about visual information.
It does.
It makes you wonder if we could use this knowledge to make our lives, easier or even more beautiful.
Absolutely.
How so?
Well, imagine designing a city park.
Okay.
where the landscaping, the benches, the pathways, everything is laid out in a way that intuitively guides people.
Right.
And just, feels visually harmonious.
I see what you're saying.
Yeah.
Okay, yeah.
Or a museum exhibit where the arrangement of artifacts kind of naturally leads your eye and helps you understand the connections between them.
That would be amazing.
Right.
So understanding visual clustering could, like, revolutionize the way we design spaces, communicate information, and even create art.
I think so, yeah.
We've always been told that beauty is in the eye of the beholder.
Right.
But maybe there's a deeper, like, shared understanding of what makes things visually pleasing.
That's a fascinating thought. Perhaps there are, universal principles of visual organization that appeal to our brains, even across cultures.
This deep dive has given me, like, a whole new appreciation for the power of visual clustering. I'm going to be noticing patterns everywhere now.
I know, me too. It's like we've been given a secret decoder ring for the visual world.
Huge thanks to our listeners for joining us on this exploration.
Yes, thank you.
We hope you've enjoyed it as much as we have.
It's been fun.
And remember, the next time you're looking at anything, a starry sky, a crowded street, even a pile of laundry, just think about how your brain is making sense of it all. You might be surprised by what you discover.
You really might.
Until next time, keep those minds curious and those eyes open to the patterns all around us.